Hello, everyone, and welcome to another episode of OpenObservability Talks. I'm Dotan Horvitz, and here at OpenObservability Talks, we talk about anything DevOps, observability, and open source. The podcast is available on all the popular podcast apps, and if you're not aware of that, we're also live streaming all the episodes on YouTube and Twitch, so do tune in, and it gives you also the option of typing in your questions, comments, and take part, which makes it much more fun. So looking forward for that. And with that, I'd like to also thank our sponsors, logs.io, for backing the podcast. And if you have something interesting that you'd like to share, just feel free to reach out and suggest your topic on the webpage, openobservability.io, or on Twitter at OpenObserve, or to me directly at Horvitz. So whichever way it works for you, we'll be more than happy to have more community members taking part in this. And with that, I'd like to move on to today's episode. And today I have the pleasure of hosting Yuri Shkuro. Yuri is a software engineer who works on distributed tracing, observability, reliability, and the performance problem. Yuri is the author of the book, Mastering Distributed Tracing. He's also the creator of Jager project, open source, that we've been talking about quite a bit here on the podcast, and many more. I'll let Yuri introduce himself. So, hey, Yuri.
Hey, Dotan. Thanks for having me.
Thanks for joining me, and great to have you here. And maybe we can start by you telling us about the many things that you do in this realm.
Sure. I mostly work in observability space, probably for the last 6 years, starting at Uber. So I started originally with the distributed tracing space because that was the area at Uber that was sort of underinvested and there's no solution in the company. And later on, I kind of extended to cover other telemetry types and overall observability solutions, both at Uber and at my current company.
Today you're at Facebook, right? You're
correct. Yep.
And you're still in around the observability and the related spaces, so
yes,
from different angles. Great, and maybe just to remind the listeners that Uber was essentially in your tenure at Uber. That was the time where Jaeger was born, essentially, and first as a tool internally for Uber, and then later on contributed as an open source and under the CNCF, right?
Mm-hmm. Yep.
So maybe I guess let's start with a very basic question, but one that I keep encountering quite often. We've been using logs and metrics for monitoring for many years now, and it served us very well. So many people ask why distributed tracing is needed, and why is that considered a separate, distinct pillar in observability?
Yeah, that's a good question. In the kind of first approximation, distributed tracing is just a more structured form of logging, right? However, there are two significant differences in how it's done. The one difference is that distributed tracing keeps causality between the events, so that, for example, if you have a big monolith application which is doing a lot of different processing on a particular user request, and it's a multi-threaded application, so it's doing handling lots of different requests. Just traditional logging would kind of jumble all of that into one pile of events that you kind of need to go visually separate in your head, whereas distributed tracing will keep track of relationships between those events, even within this single monolith app, right? And so it can give you a very detailed picture of all this request. This is what it's done, and it can easily ignore all the other requests, which is something that it's difficult to do with other telemetry types. And there is sometimes an objection. Well, in logging you can log a request ID, but as soon as you start logging request ID, you kind of doing distributed tracing in a way, because this is how distributed tracing works. And so if you let distributed tracing do its work, you're going to get the same thing with other benefits, right? And the second aspect of distributed tracing is that not only it correlates events within the single process, it also correlates them across the processes, which is why distributed part of the name comes from. And why is that important is that then it gives you an ability to do things that you cannot do at all with any other telemetry type. And here's an example. You deploy a new version of application, and you look at your health metrics, your application looks fine, no errors in the logs, everything good, right? And then suddenly you get basically a page from your upstream consumer saying, oh, you blew us up, right? And so this is what distributed tracing can catch, right? It can you can actually build your deployment pipeline in such a way that you're not only looking at the very basic health signal of your application, but because from traces you know that how your application is going to affect the rest of the stack, you can actually start monitoring other signals and catch that situation before it affects your users, right? This is like a unique value proposition of distributed tracing because it allows you to have a picture across the stack and not just one single service.
And I think it's important to also note, especially in distributed systems, that it also goes through async invocations, which is obviously the classic pattern for distributed systems, right? How does it work when I work in an async fashion, probably through some sort of a messaging queue and other layers in between?
Yeah, so that's really not much of a difference for distributed tracing. It's not particularly tied to the way that your processes communicate between each other. The only requirement it has is that whatever communication protocol you use, it needs to support some sort of like a context metadata within it, right? And so if you, let's say, if you're using, I don't know, a messaging queue like a Kafka, at one of the versions introduced the notion of record headers, where it's a key value pairs where you can essentially stuff some metadata such that none of the actual payload is affected. And so the applications consuming or producing messages don't even need to be aware of the fact that you're passing something. But by having that capability in the protocol, you allow features like distributed tracing to exist. And because it can be done transparently to the application code in this case, right? And so, yeah, whether it's asynchronous communication or synchronous is irrelevant, really. It kind of, the only thing that changes with asynchronous communication is you need to think slightly more about what you mean by a request or a trace, right? Because in case of RPC world, it's kind of, you can imagine it as like a graph or a call stack, where it's like top level service receives the request and then it calls a whole bunch of downstreams, combines the result back and responds to the user. In asynchronous world, that sometimes can get tricky because you may have things spawning other things. You may have like coalescing behavior happening, like maybe several messages are merged and produce something else. So the modeling aspect gets a bit more difficult. But it's not like a technological challenge. It's the actual modeling challenge, what you want to represent with a trace.
And you said that in terms of propagating the headers that contain the context, it's something that is widely supported. So it's not a challenge in its own right.
It could be a challenge because a lot of proprietary protocols do not support this metadata propagation. Like classic example, MySQL protocol, right? When you talk to the database, I don't think it has any sort of notion of metadata that you can attach. In fact, you mentioned that you wanted to talk about like SQL commenter, right? The reason why that thing exists is because, well, there is no place for the protocol, and so why don't we just stick that in the comments, right? These comments are kind of like a metadata where you can put stuff. So great, but this is like a workaround for the deficiency of the protocol itself, right? And whereas if you pick other protocols, also proprietary, but let's say Cassandra, has a proprietary network protocol, but it does support metadata, and so tracing works beautifully in Cassandra as a result.
So, in essence, tracing presents a lot of benefits, especially for these, I guess, modern systems. But then, when you talk to people, I think at least what I see is that it's still not widely enough known. Certainly not in comparison to logs and metrics. And I'm curious, what's your perspective? Why do you think that is?
Yeah, this is a good question, and I think the industry still struggles with defining very easy workflows to use with the tracing, and that's the main reason we haven't really come up with very clear solutions to that. The tracing data which is collected is exceptionally rich and very useful, right? And you could build all kinds of processing that we may talk later about this. However, that data is much more complex than just the regular logs. It's like when you think about it, you need to reason about not just your applications, but also, oh, there is a specific data model in which tracing data is represented, right? And you kind of need to understand that model in order to make most use of it. So there's already a bit of a learning curve for people. And then the visualization tools, sort of like they don't really make that data easily consumable. And so I think that it's a growing pain in my view. The sort of like the need for this data is very clear, but the consumption of that data is not very well implemented yet. And consumption, like you can think of two ways. Like one is a simple, well, do I have a UI which gives me easy understood insights from the tracing data, right? This is how you make the data kind of popular among developers, and that's the part that's missing today. Whereas another consumption said, okay, well, if I have that data, can I write a program and start getting insights from the data? And absolutely you can. And this is like one of the huge value propositions of traces. Like this is how many big organizations are using it. Like Google, who like technically pioneered this whole tracing. This is their primary use, right? Like the resource utilization based on traces and all kinds of stuff.
So I think these are definitely inhibitors that I keep encountering. The visualization that is limited, but I think one other aspect that I would bring, at least from what I see, is that the challenge of the instrumentation itself. It seems that from my feeling is that many organizations don't really know how to set out with the instrumentation, especially when they have a polyglot organization with several programming languages and frameworks and things like that, and they need to gather all the different teams, different owners of the different components and services and so on, and get them to do that systematically. And I guess also the challenge of too manual instrumentation still in many fronts. So it's still too far away from what we would like to see in automatic instrumentation. So do you encounter these challenges with instrumentation?
Yeah, that's, I think, is a very valid point to add to what I said. It's a bit of a chicken and egg problem, is that when consuming the telemetry data is very easy and intuitive, then people tend to add more of it into their code and instrument the code, right? And so adding a log is trivial. Understanding the log is also trivial, and so people do that. Whereas instrumentation for distributed tracing, yes, first of all, if you're like in a completely green field, it is challenging because you need certain frameworks to be in place before you can even start collecting. Like, let's say you are a developer and saying, I have this property of my application or my request that is really important for debugging, and I want to add it to the trace, right? Well, that's trivial, but you have to have the infrastructure already in place for collecting the traces in the first place, right? And so what we tend to call this out-of-box tracing, to collect the skeleton information, right? And that historically has been sort of a challenge without a solution in the industry. So out-of-the-box instrumentation, or auto-instrumentation, as it's called in OpenTelemetry, is a problem. Like, I mean, it's not easy to get right. For a long time, it's been in the purview of vendors and proprietary solutions, and so as a result, you couldn't just get it from any application. Whereas with logs, I mean, you can always write a log, and you don't need any kind of dependency on the vendor, right? And so that is an area that this definitely is a challenge. So in terms of like how you deploy tracing. But when I said it's a chicken and eggs, like if you have an incentive to deploy it, then you find a way to deploy it. But it's sort of like you need both to work together.
Yeah. Yeah, and then anyway, once you have the baseline, even if it's based on auto instrumentation and you get familiar with it, then you can augment it with manual instrumentation on specific pieces of code where you want finer granularity. But at least you have the infrastructure in place, you have the trace to take the context to take the span, and then do the manual on top of the auto instrumentation that is already there. But getting through the threshold is, I guess, something that is. We work in the industry, you know it better than me, even to try and lower this barrier to entry to make it easier for people. By the way, do you see it? Is that the same across the different segments, across different languages, and I don't know, or do you see like that tracing more popular or more common in specific communities that you encounter?
I feel that because of the need for auto instrumentation and out-of-the-box instrumentation, tracing gets easier path in languages where you can do like auto instrumentation easier than in other languages, right? So,
like
for example,
code instrumentation,
exactly,
or
like the monkey patching or hooks, or like wherever you can basically change the behavior of the application without touching the source code. And there are many languages where that's possible, like Java, Python, Node.js, right? You can do there. And then, but there are other languages where that's just like not possible. Like in C++, I'm not aware of any automatic instrumentation. In Go, you kind of have to do the work in some way to put that stuff, and that's obviously raises the barrier to entry for any sort of tracing solution in those languages. And like ironically, this is also a different philosophy in languages, right? So like Go is very explicit about not wanting to have any sort of magic happening in your application, which is auto instrumentation is kind of a magic experience, right? You don't like, it happens without you knowing. And yeah, so like Go says, no, we're never going to support this, and therefore, well, then like the ecosystem needs to evolve in a different direction.
Yeah, which is funny because Go is the preferred language for many of the CNCF projects that we talk about around observability. But Go in itself is a challenge for instrumentation. So yeah.
Well, Go is kind of very interesting in that regard, because on one hand, it's a challenge for auto instrumentation in a way that you cannot, let's say, attach a middleware to your web server without going into the source code and actually injecting it, right? Yeah. But on the other hand, Go is probably like one of few languages which has the context object built into the standard library and promotes the use of that context object through all the user code and through all the APIs, right? And so it simultaneously makes it more difficult and easier in some ways to do the context, to do like tracing, because if for example, in my experience, when we were trying to sort of like compare in Go ecosystem and Java ecosystem, right? In Go, yes, you need to have middleware installed, but because middleware, there is not that many frameworks that typically your organization is convergent to in terms of like what server framework I'm using, what client frameworks I'm using, right? There is a sort of like a well-established leverage points, and so if I'm as a tracing person and I need to build a middleware, I have a well-defined point where I can do it once and it will affect the whole company, right? Whereas in Java, I don't need to have that dependency because I can just like magically manipulate the bytecode and install my instrumentation anywhere I wish. But the context propagation in Java is much more difficult, because then you have to sort of know every time there's a thread change or something future getting spawned off, you need to have context propagation working. Whereas in Go, you assume that the application developer will take care of it because that's how the language promotes
philosophy of the language, yeah.
Right. And so like to me, the context propagation is always the more challenging aspect of instrumentation than the sort of like a middleware instrumentation. And in Go, context propagation, you pretty don't worry about it because it's like usually is there already. So yeah, it's kind of hit and miss in some ways.
Yeah, and I think we again the tracing keeps coming up in the context that typically in the context of monitoring, and let's check now the performance issues in my system, where the latency resides and things like that. But in fact, once you have the mechanism in place, once the system is instrumented and you have context propagation across your system, you can actually do much more with tracing beyond just a pure monitoring case study, right? We can take it and gain observability into different dimensions, even business type of visibility into our flows, right?
Yeah, well, context propagation by itself is something that is independent of the tracing, right? Ideally, I would like to be in a world where all distributed systems implement context propagation out of the box, right? Because that would make tracing jobs so much easier. But that's not the case. And so in practice, what often happens is that when people are instrumenting systems for tracing for observability, they also, on the way there, implement context propagation, and then they find a way, you know what, I can actually do other stuff with context propagation. Sometimes it's the other way. Like, for example, a classic, I think, example is Envoy at Lyft was able to provide distributed tracing because they had context propagation built into the software from the beginning as a standalone feature, right? And Envoy wouldn't be able to provide traces without context propagation, but because it was there, they were able to do that, right? And so,
and today it's the norm for service meshes. It's a given for any service mesh to offer that, and by that also support tracing built in.
Exactly, but again, like the only way service meshes can support it is if there is a context propagation in the services, right? And because service mesh by itself cannot provide that, and so that's sort of like they often like withhold this fact from the marketing materials, but that's definitely the case. And so I'm not sure why Lyft had the context propagation built in from the beginning. They might have had like other use cases, but this is a good foresight on their part, right? To develop a software in this way. Like every distributed system should have that. And so when you have context propagation, the things that you can do are definitely beyond the scope of monitoring. So like you can use that for privacy purposes. Like know who your user is, right? It's like typically the only place in the architecture who knows that who the user is your top tier, and then by that, like as you descend into like a data stores, either you explicitly propagate it, which is kind of you rebuild in context propagation in some way, or you lose that information, and then you have privacy issues where like access to the data which shouldn't happen can happen, things like that, right? And so propagating like with either user identity or some sort of other privacy policy settings that can affect the behavior of the systems. That's one example. Another example, which I really like, is that context propagation helps you in the sort of developer experience world. There are tools already. I think like telepresence is one of the sandbox projects in CNCF, where if you're running a service in production, how do you debug that service? You can't just put a breakpoint in a live application, because then like you handle it like hundreds of requests per second, like they're all gonna hit that breakpoint, right? So you kind of need to be able to target specific instances of the service for specific requests that are originating from, let's say, from you as a developer, if you're running it like whether from your mobile app or from the browser or from some like fiddle tooling. And context propagation is the way you can do that. You can essentially tag the request, make sure that that context passes around, and by the time it reaches a certain service where you want to breakpoint, you make a breakpoint conditional on the presence of that label in the context, and then you only affect your request and nothing else. So there's like a lot of other things you can do with like in a similar way, but this is like a very strong example, which is unfortunately I'm not seeing it yet in the industry used that much, but I think it will eventually kind of get there. Once the very user-friendly solution shows up, then it might be happening. I mean, Uber actually did something like that on at the company level in as a general solution where you could. They did it slightly differently. It's not like you're not putting a breakpoint in the service, but instead you run in your local instance of that service, and then you can forward the request to your instance rather than hitting the standard production pool, right? And again, you do that by like tagging the request with saying, yeah, this is a debug request, I want it to route it differently. And so by the time it reaches like 5 levels
like
down,
a canary, but based on the specific request, selective request being rerouted to a different path.
Exactly, yeah. And so, yeah, so that was like built as a generic solution, so lots of services would be able to use that.
Nice. No, these are cool examples. I think in other topics that at least I keep fiddling with are more around, let's say, types of FinOps. Let's say today many talks about how you can calculate your costs, how you can manage your costs, especially in distributed systems and so on. And I think because of the nature of distributed systems, once you have context propagation through your system, then you can track per request type or flow and tie back the resources downstream, even to the level of database resourcing required or infrastructure required, tie it back to the business unit that invoked it, or to the specific customer if it's a multi-tenant or something like that. And then it becomes much easier for calculating and doing all this, attributing the cost to the different tenants, business units, teams, and so on. This is something that I actually find very, very interesting and very relates very nicely to all this very relevant topic that everyone is talking today about FinOps and how you can manage this cost attribution and maybe even do capacity planning. You need to plan ahead, but you have one tenant that is we run, for example, a multi-tenant solution. So you need to balance between different tenants and the resources, or organizations that are very, very large. Uber, I'm sure, is a classic example for that. And then you need to plan, but per the growth of each business unit and each segment. So is that something that you came across?
Yes, and I think this goes nicely back to your question about why is tracing not popular? Well, sort of like it's popular, but it's not widespread in the industry. But it's because people are focusing on the wrong aspect. They are focusing on this specifically like a DevOps workflows, for which, yes, there are sort of like half-baked solutions in the industry today, and we're trying to find ways. But what you're talking about, that's actually fundamentally what tracing at big companies has been doing all these years, right? It's not something that you have a UI for. It's really you process the data in bulk, you like build insights, but it's extremely powerful mechanism for doing this kind of like accounting and resource attribution, and at scale that large businesses operate. It's sort of like a 1% saving in CPU is like lots of money, right? And so this is where you invest, and it's kind of I remember Ben Siegelman, who was the author of Dapper, like I had the chat with him once, and he mentioned like, if you want to have like the biggest impact from tracing, like this is the area to invest. Because it's the easiest way to get impact is the resource utilization derived through traces, right? And like to add to the examples that you mentioned, like one other example is very clear. Is let's say you are developing a new feature, and usually people have like feature flags that control whether the feature is available or not. But then, how do you actually evaluate what is going to be your resource utilization for that new feature across the whole architecture, right? And like if you're a company like Facebook running like I don't know how many data centers, then yeah, there's like a feature which takes new computing resources could be very expensive, and so you want to make a business case like, is it going to like bring more money to the bottom line versus the resources it's going to consume, right? And how do you do that? Like the tracing is sort of like the only way that can track your usage of that specific feature. Like you can again label your request in the context and look at what the rest of the architecture is doing with this request, accumulate it and like present it, say, yeah, this is the difference in the consumption for this feature versus a normal flow, and then you make business decisions based on that.
That's amazing, and that actually brings in more, I think, personas in the organization that are not DevOps focused, but have different, they're responsible for, again, whether the FinOps side of things or the business side of things, and that can actually benefit from the same infrastructure, which can give, again, more backwind in the organization to support instrumenting the applications and going about this path in context propagation. Yeah, that's amazing. And going back to you mentioned the industry having half-baked solutions for DevOps. Going back to the DevOps use case, so how do you see it today? How do you the landscape for DevOps observability and the tooling that to support this sort of tracing and context, showing the flows through distributed systems in an effective way, the way that you mentioned, envisioned it.
Yeah, I feel that the way that the industry at large so far approached the sort of observability overall is by saying, oh, we have these pillars and we need to make them all work in isolation and improve individually, right? And that just doesn't work very well because you really want to combine the telemetry signals into one coherent experience. And it doesn't mean that you necessarily need to jam it all into one UI, but you need to build certain workflows in the UI that kind of make use of all the available signals when it's beneficial, right? And so when, especially again, a lot of developers are not experts in sort of in observability space, in necessarily like troubleshooting, right? And so you want to make the consumption of this experience very easy for regular developers, like product developers. And so when they come to a page for a service and they're trying to investigate an issue, you want that front end to lead them through the workflow, right? And then if that workflow needs to start with the metrics and then switch to traces, great. I mean, it should do that without really making a big deal about it. It's like, why do you care what data we're showing you? We're just like showing you the data and you get the insights from it, right? And so that so far, I haven't seen that happening that much. It's sort of like most of the solutions are kind of separate. And you have they may be like on the same UI, but it's a different tab. You're looking at the logs and then you go to a different place to look at traces. And so I think there's a tendency now that like some of the companies are trying to integrate this more, and sort of like Grafana does this presentation about Loki, which is a login backends, like how it fits into the investigation workflow, right? And they're saying, well, you get an alert, you start with metrics, you look at the metrics, then if the system can correlate the dimensions of the metrics with the dimensions of the logs collected, then you can switch to the log view to like once you've narrowed down some of the problematic behavior in the service from the metric space, you're saying go into the logs and then look at the stuff, and then maybe you find something even more interesting and say like, oh, this is a trace ID, go to the traces, which is kind of, okay, it's a good step, but it's still sort of like walking you through separate experiences, whereas, well, why couldn't your sort of like a metrics picture be combined automatically with like inference from the traces and saying, if you select this time range in the time series, this is the explanation that we've seen from the data. Maybe it's caused by this client ID multiple hops up, right? So this is the experience I think we need to get to make this more kind of useful and intuitive to people.
I think this is a challenge. Combining all the signals, the enrichment of the systematic enrichment to enable this correlation is a challenge. Grafana took a certain approach to make sure that the labels of the Prometheus labels are the same labels that they index on the logs or similar. So this is one approach. Other ones took different approaches, but you obviously have the exemplars that aim to attach the ability to drill down from the metric to a specific example trace and so on. But it's really the beginning, as you said. It's a challenge, and I think it's a challenge to observability because ultimately it creates silos. And the whole point I treat observability as a data analytics problem. So essentially, you want to just figure out what the heck is going on in your system. You don't really care about the different signal types or the different sources. This came from the front end, this came from the back end, this is a Java or a Python, or this is from the database or others. You want to just get the data lake, the conceptual data lake, and just ask the questions and be able to understand. But in reality, because as you said, each one is its own separate tool and each separate view and each separate maybe language and metadata and structure, it gets a bit broken, the way that you can actually effectively ask and answer these questions.
Yeah, and it even starts with instrumentation itself, right? The siloed nature of the backends spills out into instrumentation. When you're saying I'm instrumenting metrics, it's a very different API from like capture and traces. Even though if you think about like golden signals for a service, then you can capture them all with the tracing instrumentation, and you can still emit them as metrics because of the aggregation benefits, right? But you don't really have to have two separate instrumentation points, and that's not the case because they kind of evolve separately, and people have just different ecosystem of instrumentation, and which creates this problem that you mentioned with the metadata. How do you make sure that the labels are the same? And like if you don't make sure that they're the same, then it's like all bets are off. Like none of the features that we talked about in your backend can actually work because they simply cannot make sense of any of the data, right? Like endpoint here has a slash and another doesn't, and so like how do you match them up?
Yeah, actually, I see we have a question from the audience that relates to that. Eddie Shannon said that I know that APM and observability market is saturated. He names quite a bit of services out there and providers that claim that they can do that, dozens of companies. And his question ultimately is, how are our customers supposed to navigate this arena? And which directions do you think this industry is heading?
Well, competition is always good. So I think the way you choose these companies, I mean, I'm not going to be able to give an advice because it's a tough thing, and you're probably not going to look at just one single factor. If you already have, I don't know, Splunk subscription, maybe you want to get Splunk tracing as well for like 1% extra cost. And benefit from the integrations that they may have built into instrumentation, right? So these are the kind of decisions you may need to take depending on your situation. If you're like in a completely green field, then I don't know. I mean, maybe you have to evaluate and see which one of those offers. But it's also hard, I think, to decide which solution is going to work best because. Yeah, the marketing materials, they make them all look nice. The workflows, sometimes similar, sometimes different. You think that workflow will work, but until you actually try it out in your organization with your developers, you don't know whether that's gonna sit well or not, right? And so, yeah, I don't really have an advice on how you choose among them. To me, what I would again advise is that try to think about it slightly differently. So if you don't have fundamental observability data collection in place, then none of the rest really matters. You're simply not going to be able to get to the point where you get valuable insights. And so, but in order to approve the budget to instrument in the services, right, you need to have a business use case at the same time. So it's like, again, it's a bit of a chicken and egg situation, and I think which is why typically people kind of go through this 12-step program. They're saying like, oh well, I'm starting with something simple, like with the metrics, and you absolutely have to start with the metrics because you have to run your stuff in production. You need to know when it's broken, right? It may be difficult for you to figure out why it's broken, but that's the problem that you can like eventually improve on. But if you simply don't even know that it's broken, then your business suffers and your customers suffer. So this is not where you want to be. And so that's why sort of like there is a natural progression of how you start with observability view in a completely green field. Like you start with that space, you maybe like throw the logs because it's there, it's cheap to add them in terms of like instrumentation usually is already there, and so you just need some sort of collection solutions. But eventually you will start running into more and more complex scenarios of failures, and that's where you start to need more expensive like troubleshooting solutions like tracing. Unless, again, like as I mentioned, like with tracing, there's a very different use case that you can just like the resource attribution that you can invest in and get huge benefits without having the sort of vendors provide you a solution on the analysis side.
Yeah, makes sense. Now, I want to. We talked about tools, and the tool that you're one of the fathers of that. It's obviously Jaeger, and I want to maybe get your perspective of the latest on Jaeger, the recent developments, also what's heading up next. At least the main themes that you recognize for the project.
Yeah, so Jaeger is interesting because I've always thought of Jaeger as a sort of distributed tracing platform and not a distributed tracing tool, right? And the difference to me is that a platform does not necessarily give you a specific solution to a specific problem. It's a platform on which you build the solutions, right? And so what Jaeger project provided you is the obviously we've done work with OpenTracing as a sort of like a standard API for instrumenting. Jaeger provides you SDKs that implement that API, and then we provide a collection backend. With some limited query capabilities on top of it, although that varies depending on the type of storage that you use, right? And so it does serve some very basic use cases where you say, well, if I find a few traces where the latency is abnormally large, which you can do with a query support in Jaeger directly, then you can drill down into those and investigate and sort of like figure out what's going on in your service that's causing those latencies, right? So this is a very basic sort of troubleshooting use case that surprisingly a lot of people find like very useful and they benefit from it, right? Even though to me it's sort of like you definitely need to get to the next step with like providing aggregate data and deriving insights from aggregate data in order to like unlock the full power of tracing. But even that basic use case is sort of available in Jaeger, and then you can use that. But that's the only part of the Jaeger tool ecosystem. Whereas like, yes, there is a visualization for trace that you can inspect. You can potentially do some comparisons of traces, like some graph visualizations, things like that. They do help. They have some very basic use cases that you can address with that. But to go further, you really need something bigger and sort of like the aggregate analysis, and that it's never been sort of implemented in Jaeger directly, because I often found that to be kind of specific to an organization. So it's a kind of, to your point, it's a data warehouse. So what kind of solution can you provide on top of warehouse, right? It's not going to be a specific solution to a very specific business problem. It's going to be, no, it's a solution that lets you query the warehouse. That's the extent of it, right? And so that's the kind of the place of Jaeger. So like you can query with it. What kind of solution you build on top of that query capabilities or even the collection capabilities, it's more up to you. You need to invest something into that area. And hopefully, again, this is not the approach that like vendors taken, right? The vendors, well, they take that basic querying capability approach as well, but they're also trying to move into like, oh, what if we give you like very specific investigation workflows and based on the aggregate data? So that's good, right? That's sort of like, but it takes more resources to build that, and it's sometimes kind of specific to the architecture, even though maybe it doesn't have to be. So it's kind of it's a tricky position for Jaeger project because of like the overall adoption of tracing is sort of in the industry, as we said, it's unclear, and so betting on that in the Jaeger project was very difficult. And we said like, okay, let's build a basic platform and let people develop from that going forward, right? So this is where it is in terms of where sort of like what are the future things. that kind of, again, goes back to the philosophy. If you think of Jaeger as a platform, then the features that the platform provide can be improved data collection, right? And that means some sort of like a control plane of how you control sampling in SDKs. Maybe some optimizations in how you sort of collect the data, compress it, or things like that. So like basically SDK improvements to make costs lower and things like that. Then there is improvements potentially on the back end where you can, and that's where the area where I feel we didn't do so far a lot of work on Jaeger, because it's kind of difficult. It gets you into a lot of infrastructure questions. So in order to, for example, in order to provide aggregation capabilities, you need to have sort of like some kind of streaming pipeline to be built. And okay, well, we can make a choice of a pipeline. Let's say we pick Flink, and we have some of the functionality in Jaeger built for Flink. But like, I mean, you kind of have to pick the winner in this case, and there is no way to pick the winner because every company has its own opinions about like what is the right streaming pipeline is, right? And so they deploy all kinds of different stuff.
Yeah, maybe, but we should give the listeners some context. You're already in the details of how to implement and the challenges around that. But maybe do you want to say a few words just to give the audience context about what the goal of the aggregation is and what kind of functionality is expected in Jaeger around that?
Yeah, well, the goal of aggregation is really, I think the fundamental challenge with the basic functionality that exists in Jaeger is that if you know which trace to look at, it gives you a lot of tools to look at that trace and figure out all kinds of stuff that's happening with it. The trick is that how do you know which trace to look at, right? And I mentioned that Jaeger has some querying capabilities, and so you can ask, let's say, find me a trace where this operation and this service takes longer than X, right? It will find you the example traces. And so is that enough to know that these are the good traces to inspect for your like investigation? Maybe, but maybe those just happen to be random anomalies that just took longer for whatever reason, and they don't actually represent the problem, right? And so the way that you have to narrow down from the overall problem to traces that represent that problem is you can only do that through aggregations, right? You could say, for example, saying, okay, well, I know that my top line service is having an SLO issue. So if I think like virtually about all universe of traces, right? First, I want to say I'm only interested in those coming through that service. Then I'm only interested in those which are, let's say, exhibiting this like latency or their whatever the SLO that's being violated, assuming that you can measure that at that service. So those are the questions that you can still ask in Jaeger directly. But beyond that, that's where the sort of like the Jaeger functionality stops, because like when you need to go beyond that, because the next step for you is saying, well, then I want to also ask questions about the rest of the trace, saying, okay, fine, I found the traces here, but there's still tons of them. They don't really tell me what the problem is. So I need to drill down. I need to put more filters, and more filters again on the on the aggregate view of the world, right? Saying maybe what is or like I'll take it. Let's flip that problem differently. Let's say you have another type of alert where you have a database and a particular shard of the database is being overloaded, right? And you're trying to investigate that problem. So what kind of steps you would take to investigate? You said, okay, well, first of all, I need to put a filter on the shard ID. Is that thing is even in the traces, right? Is it even indexed fields? Well, maybe. Depends on your backend capabilities. Like in Jaeger, it is, but if you run it at scale on Elasticsearch, you might have like problems with the capacity of indexing everything, right? And then you want to say, okay, well, fine, I narrowed down this like to all traces which contain this specific shard ID, but then what else do I need? Like, can I actually group by the activity of this thing by, I don't know, by region or by cluster or by rack or something like that? And that sort of like Jaeger already stops there. You can't really ask that question. Definitely not from the UI. Sometimes the backend store, like in Elasticsearch, you can potentially ask that question directly, but not through the UI. And then but then this is like, you are not really asking important questions about the traces, because your next question is, okay, great, now I've isolated this huge stream of traces that kind of exhibit this problem in this chart, and I'm trying to understand that. And my next question is really going to be, okay, what's causing this? Is it some downstream of that chart that's having an issue? Is it some like upstream traffic pattern that I'm not understanding yet that's causing this? Maybe it's a specific client ID that's kind of sending some weird requests that are all hitting this chart, right? Now you need to start asking these questions of this stream of traces that like no backend that I know of really supports today. And you can only ask them again, you're still doing the aggregate analysis, because by the end, what you want to end up is like narrow down your full stream of traces through these aggregate questions to some samples. And only then you might want to go and say, okay, well, let me actually finally look at the trace and see what's going on with the details. Maybe you don't even have to get to that point. Maybe you will get your answers by just aggregate analysis.
Yeah, that's just we're just starting to scratch the surface around these capabilities, and actually, I'm really thrilled seeing the type of work that my colleagues at Logs.io do around the aggregated span metrics and trace metrics as a step to bring it into both OTel and Jaeger as the backend side of things, which brings me also to OTel and Jaeger. You mentioned Jaeger taking care of the vision of the platform being both the instrumentation, the collection, and then the backend. But now, given that OpenTelemetry, or OTel as we call it, is there, I think Jaeger as a community, we decided that we are shifting this responsibility to OTel and then focusing more on the backend side, right? Can you talk about this shift to OpenTelemetry?
Yes, and I think the fact that Jaeger had to focus on instrumentation side was not something that we wanted to do. It just, we had to do that because there's no other way to get data into Jaeger backend in the first place, right? And so we had to develop SDKs, like work with OpenTracing standard to develop that. With that piece now being replaced by OpenTelemetry, I think we can actually sort of retire those parts of the Jaeger project and say like, yeah, let's converge all onto OpenTelemetry, because there's not a lot of unique features in the Jaeger SDKs which are not already in OpenTelemetry. The only like remaining unique feature is the control plane for sampling that exists in Jaeger SDKs, where you can control sampling from the backend. And so like we're also working on the backend. We just recently merged the PR to finally implement the adaptive sampling in the backend, where it can monitor what kinds of traffic and what kind of services and endpoints exist in your architecture, and decide automatically what sampling probabilities are appropriate to each service in the architecture, which is usually like a very huge maintenance challenge in a large organization, because there's like no one really knows what kind of sampling is appropriate, and it's very easy to screw up your backend, tracing backend, by using the wrong sampling and just flooding it with the data, right? And so in Jaeger now, finally, we have that feature. It was working at Uber for several years already, but it just made it finally in the open source. To kind of have that automatically managed by the backend. However, the control plane, it's tightly dependent on the control plane that exists in the SDK, basically this ability to remotely control the sampling decisions in the SDK. And that is still not part of the SDK in OTel. As a result, so we kind of in this waiting pattern. When it's implemented there, that would be finally the step that we can say, yes, we are ready to retire Jaeger SDK, because they don't provide anything new over what's OTel providing.
And also the collector, right? The collector will also be deprecated in favor of auto collector.
Well, so not quite. So the thing that we were trying to do with Jager Collector is we were trying to re-architect it so that it could use OTel Collector as a basic framework. But Jager Collector fundamentally has the Jaeger-specific functionality of converting data into storage and writing it in storage, right? That's part of the functionality that's never going to be part of OTel Collector, because that's not the purpose of that technology. But for us, it would be beneficial to kind of base Jaeger Collector on OTel Collector, because then we can, like OTel Collector already kind of accepts all the legacy Jaeger SDK formats, right? And it also accepts the like hotel native format to TLP. And so by sitting on top of that, we could just like basically as well remove the need in the Jaeger project to maintain those things and just say, we're just going to work like with the how we store the data, and then maybe finally move on to how do we do aggregations and processing of the data. So like the analysis part of the distributed tracing and not the collection part.
Yeah, that's looks very, very interesting, the way that we can join forces with OTel and get more power out of there, and also focus, as you said, more on the backend framework for the data analytics part of the equation. So unfortunately, we're about to run out of time. I did want to leave some time for the news, and I'd be happy if you have the time to join me for a couple of news and maybe get your bits on these.
Sure.
So with that, let's move on to the breaking news. And the first one, really happy, glad to say that OpenTelemetry has officially become a CNCF incubating project. So this is quite a happy announcement. And looking at the maybe looking forward, I'm looking here at on the announcement. One of the interesting things that in the looking forward plan, they mentioned the team plans to add a goal to achieve the 1.0 stability for all the beta instrumentation libraries and collector tracing stability for tracing capabilities. In addition, for the metric specification, they expect to reach 1.0 soon, and will include full Prometheus and Open Metrics compatibility. So quite some encouraging. And on the front that you mentioned about OpenTracing, also Open Census, both will be further deprecated in the coming weeks, with OpenTracing being formally archived by the CNCF TOC. So these are great news. How do you see this progression, this milestone?
Yeah, it's been a long road to incubation, for sure. I think the main challenge we had with the perception of the readiness of individual pieces of OpenTelemetry project, because the scope of OpenTelemetry kind of is pretty large. Like you have to handle all the telemetry signals, and what we didn't want to do is to just predicate on every single telemetry signal to be in a 1.0 state, because then we would still be like in sandbox for another year. So I don't know when the metrics are going to be ready. And logging is like,
not to mention logging, yeah.
Yeah, support for logging is even like in a different category altogether, because we're not even providing API SDK for logging. We're only focusing on sort of like a log collection pipeline. So yeah, and so I think that there is sort of like a realization that there are different maturity levels within the OpenTelemetry project because of the large scope. It's just like it's impossible to kind of say like predicate incubation on everything reaching maturity. And so that was finally the agreement that was made with CNCF, and we got to incubation.
Yeah, and maybe in that context, in this round, we also got many other projects accepted to incubation. I guess the most important ones for our show and for observability that caught my eye are Thanos and Cortex, both of which are projects that we've covered in the past in past episodes here on the podcast. So this will also be an important milestone for these options to extend Prometheus, to scale Prometheus, long-term storage solutions, and so on for observability solutions. Another one that we mentioned briefly on our conversation is Google's donation of the contribution of the SQL commenter project to OpenTelemetry. And that's actually quite an interesting one, because as we said, when you have the database and you want to correlate what's going on in the database with your application, it's something that is not standardized and sometimes not even facilitated by metadata capabilities. So the need for common standards for application tags and traces to be sent to the database and then correlated with the application stack is something that is definitely needed. And the SQL commenter, the nice thing is that they plug into the common ORM libraries. So if you're a Java programmer and you use Hibernate, or if you use I don't remember which other types they have on the latest list, but essentially I think they contributed all of them. Then you just auto instrument these libraries, and then you ride on top of the ORM to enrich and create these comments, as you said, ride on top of the comments and put the metadata there. What are your thoughts about this contribution?
I think it's a very interesting project. There have been a few questions about specifically whether contribution needs to be in OpenTelemetry. So this is always the discussion that we have when there's a donation proposal, right? Because one of the things, as I mentioned, like even with incubation, we already had issues with the scope, and so SQL commenter, like it is like pretty large scope already, and so that sort of like increases the scope of the overall OpenTelemetry project. Yes, there's a huge synergy, but it also like we have to be careful with sort of like accepting all the donations just blindly. And so, but yeah, as a technology, I think there is a lot of synergy with OpenTelemetry. Like auto instrumentation kind of works best when it's consistent, and there is the protocol part of SQL commenter is probably the most important piece. So like agreeing on a standard way of representing metadata in the comments, great, but it's a creative solution, let me tell you. But like if we have that as a kind of common layer, then we can actually work with the database providers and say like, well, can you interpret that and do something interesting within your process as well with that metadata, and maybe emit some additional data, and then we get better observability on the databases.
Yeah, and I'm looking now quickly. I see that they said that it's available on Python, Java, Node.js, Ruby, and lists here Django and Hibernate and Sequentialize and Rails and so on. So it's pretty vast. And yeah, it's a missing building block on relaying this information down to the database layer. And the last bit of news that I wanted to cover is from Kubernetes, that version 1.22 release has an alpha release of the API server tracing based on OpenTelemetry. That was led by the Kubernetes SIG instrumentation, the special interest group. And the idea is that to target the Kubernetes API server, because first of all, it follows the standard RPC model, so it's a request-response type of communication that's easy to instrument, and then it's obviously latency sensitive because it's a gateway, and you can't really afford many seconds there latency. It's impact immediately, and it fans out. The service topology means that each one will probably have quite a bit of webhooks and other downstream that will be invoked by it. So it's a classic candidate, and it's baked into, as I said, Kubernetes API server. So how do you see this contribution and being a part of Kubernetes?
I think it's great. This sort of instrumenting the deployment, resource management and pipelines is definitely an area where, like I know in many companies, that people investing in that because it's very complex workflow usually, and so when something goes wrong and troubleshooting it is very difficult, and so tracing is kind of the perfect candidate for troubleshooting them. It's also at the same time creates unique challenges often for tracing backends because the deployment workflows are very often long running, and so you are, even though you kind of start with the RPC API server layer, but you actually end up in the overall workflow that can take hours sometimes, right? Deploying to like rolling out deployments into like canaries and then by region and all of that. And so tracking all of that as a single trace it's kind of becomes challenging for the tracing backends because they usually have sort of like a short window aggregation periods before they can say, yeah, this trace is done. So it's great, but it's also a challenge. At Facebook, we have almost like a completely parallel system for this kind of workflows, which is not like it still back bridges the data into the tracing backend, but it's done in a different way.
Yeah,
the collection pipeline.
But then again, I think that it's something unavoidable. So it's part of the maturity of adopting. We talked at the beginning about being slow on the adoption of tracing, but this is fast forwarding a few years. This is where the industry will probably reside. So I guess the tooling and the frameworks should align to support this, because this is where we want to be. We want to be able to have deep instrumentation into this framework, and I find it's a very important step in this direction.
I agree.
More components within the Kubernetes and other containerized frameworks and cloud infrastructure to help us drill down into these tiers as well.
Mm-hmm. Yeah, and I think like the backends can evolve to improve the situation of handling these traces, but the fact that you actually start getting the data in the first place, that's the milestone that you want to reach. Without that, there's nothing else can be done.
That's true. Anyway, Yuri, that was a fascinating talk. Thank you very much. I'm really sorry that we have to stop because I have so many other questions to ask you, but thanks a lot for sharing with us your insights on tracing, on Jaeger, and the ecosystem in general. And thanks a lot for joining me here.
Yeah, thanks for having me.
Great. And with that, I'd like to conclude today's episode of Open Observability Talks. Thanks again for Yuri for sharing us. And just to remind you all the episodes are available on your favorite podcast apps or on our YouTube channel. So check them out. We also, if you are listening to the episode on the app, then know that we do stream the episodes live on Twitch and YouTube Live. So you're more than welcome to join in and share your questions and comments and take part of the discussion. You can find all the details on the OpenObservability.io website. And you can also reach out via Twitter at OpenObserve or reach out to me directly at Horowitz, HOROVITS, whichever way. And follow us. You're more than welcome to also get involved. If you have any interesting bit that you think that you would like to talk about here, reach out through OpenObservability.io and submit a CFP, and I'd be more than happy to catch up and discuss. And without thank you very much for listening. I'm Dotan Horowitz, and see you on next month's episode.